So a very warm welcome to this afternoon's webinar. My name is Liz.
And I'm Charlie.
And we are members of the NRICH team. We're based here in Cambridge. It's lovely to see you all with us. We do want to say a grateful thank you to Trinity College here in Cambridge, who fund these webinars for us so that they're free of charge for you to attend, and we very much appreciate that. So whether you have been to one of our webinars or not, you are very welcome. But we're quite excited because today's webinar marks the end of a series of 9 webinars that we've been doing over the last 18 months or so. And just to give you an overview of that series, I'm going to share the NRICH website, because it just makes it slightly easier, I think, for you to have a visual as I'm talking. So this is the NRICH homepage. I'm hoping that many of you are familiar with this. For you as secondary practitioners, we would suggest that the secondary teacher landing page is the best place for you to go by default, if you like. Now, what we have just coming to the end of these 9 webinars, as I say, we have been focusing on ways in which you as practitioners can develop students' mathematical thinking and their positive attitudes. So I'm just going to click very briefly on the mathematical thinking page to show you that we have we've led webinars and we've written guidance on these 5 main elements of mathematical thinking that we've identified: exploring and noticing, working systematically, conjecturing and generalizing, visualizing and representing, reasoning, convincing and proving. Clicking on any of those pages will take you to our written guidance and a recording of the webinar. So that's where we started off our series, and then we've more recently moved on to our Developing Mathematical Mindset series. And you can see here that we've identified 4 mathematical mindsets. So we want to tap into students' curiosity. We'd like to find ways to encourage them to be collaborative. As teachers, we would like to equip students with different ways to tackle problems so they can become more resourceful. And that brings us to today's webinar, where we're focusing on encouraging students to become more resilient. Again, clicking on any of those links will take you to written guidance, groups of tasks, and recording of webinars. And we will put, obviously, today's recording there too. So just having given you an overview of where we are, let's turn our attention, shall we, Charlie, to being resilient. That's why we're here. Charlie and I are rather excited by this topic. It's really got us reading quite widely around, and I think we're going to start off with a sort of a bigger picture overview. We're going to delve into some psychology, Charlie. So I'm going to hand over to you.
I'm going to do some writing, Liz.
Yeah.
Could we share?
Indeed, we'll share the visualizer. So hopefully you can see this piece of paper. There we go.
I'm just going to bring it up a touch.
Yeah, nice. Once you start writing, I'll do a double check of the focus.
Okay. Yes. So I've been listening to Csikszentmihalyi, who wrote a book called Flow quite some years ago. And I've tried to capture what he's saying, or I'm going to try and capture it in a chart, in a diagram. So the way that I'm interpreting what he was saying is that if you think about what we're experiencing, we might have sort of 2 domains. The level of challenge is something that, as teachers, we need to be thinking about. And so we're going to have the negative or less of a challenge there and more of a challenge as we go along the axis. And the skills required to engage with whatever problem we're giving our students. And again, sort of less there and a lot there. And so we can imagine splitting up this chart into 4 cells, 4 quarters. Now then, we wouldn't want our students to be in this bottom left-hand corner.
No.
They're not being challenged, and they're not required to use much in the way of skills.
No.
So I can imagine boredom setting in.
Yep.
Apathy.
Yes.
They're not engaged. They let me just focus that a little bit.
Oh yeah, that's better.
Okay. So that seems to be the worst state for students to be in the classroom. We want to
avoid that situation.
Now, let's imagine we go up to the top left-hand cell, where students are using more developed skills, but the challenge is still lower than what they could be achieving.
Yeah. Okay.
So the way that I'm picturing this is that the students will feel very comfortable here.
Yes.
They'll be in control. They'll feel quite relaxed.
Yeah.
Now, we want our students to sometimes be in that. If they've been learning something new.
Yes, initially.
And they're developing some fluency and they're rehearsing a skill.
Yeah.
I want them to get to the stage where they feel, oh yeah, I can do this.
Yeah.
But us as teachers are going to be thinking, okay, you spent far too long being relaxed. I think I need to challenge you more.
Right.
And, you know, the PE teacher will say, no, I think you can jump a little bit higher. Or the music teacher will say, oh no, I think you're now ready for Bach or for Schubert or whatever. You need to start thinking about what else might be possible.
Yeah.
Now, luckily, it seems NRICH come to the rescue of teachers here, because we want to increase the level of challenge.
Yes.
So we often talk about our problems being a low threshold, high ceiling.
Yes.
Low threshold, they're easy to step into.
That's right.
We want everybody to feel the problem is accessible,
to have a go.
Start,
yep.
and so on.
Yep.
But as soon as they start feeling a bit too comfortable, we start increasing the level of challenge.
We can drop another question.
I mean, rarely will the student ask us for that, but I think that might be
it's the role of the teacher.
The teacher.
Yeah.
So we spend a little bit of time in the top left, but not very long. So another possibility for getting out of the bottom left is to go right. And the right, you've got a high challenge, but perhaps the students don't have the skills required.
Okay.
So in this case, chances are that our students are going to feel very uncomfortable.
Yes.
They might be quite worried that the teacher might ask them to present something in front of the class.
Yes. In contrast to here, we're now sort of feeling a bit out of control.
Out of control, and some students may feel quite anxious.
Yeah.
And some might even start thinking, "Oh, math is not for me." Might start giving up.
Yes.
And if students spend too much time here, chances are they will start thinking that maths is for somebody else.
Right.
That it's
this is inherent to mathematics. Yes.
And inherent to their
relationship with mathematics.
And we know lots of adults who say to us, "Oh, I was never any good." They possibly spent too much time here.
Yeah.
So we need to increase their skill level.
Yeah.
We need to increase their confidence. So we need to increase confidence. I'm not sure I'm going to fit all this here. and skills. And actually, that's what they're in the school to do.
Absolutely.
That is the reason for turning up in our classrooms, that they're going to, hopefully, at the end of the lesson, at the end of the week, at the end of the term, they're going to feel more confident and feel they've got more skills in their toolkit. And if we manage to achieve this shift into here, this is where 6 Academy High says you're in that state of flow. The state of flow is when there's a balance between what needs to be done and what you can do. So we might talk about working in the zone of proximal development. Comes in here. A zone of proximal development. So you are responding to new challenges. And they are commensurate with the kind of skills that you have. And it's not immediately obvious what you're going to do, but you feel that it is within your grasp. And 6 Academy High talks about how life is the sum of our experiences. And it seems to us that you want students' experiences in the classroom to be mainly focused on that state where they are immersed in a problem, they're getting stuck, but feel that the solution is within their grasp. That they have got strategies. That they work in an environment where it's okay to struggle, where they can turn to their peers, where the teacher will support them where it's in the way that is appropriate. So what we're going to be doing today is mainly thinking about, we're not going to be talking about low threshold, high ceiling tasks today.
Not specifically, no.
And actually thinking about next academic year, maybe that would be a good
it might well be a good focus.
Focus for a webinar. Today's is much more about going from the bottom right to the top right. How do we ensure that students do not experience too much time, if any at all, feeling uncomfortable, worried, anxious, and wanting to give up? How do we ensure that they do that? So that's the task.
That's our task for the next sort of 35 minutes.
Yes.
Good. Okay. Well, shall we turn to our first task then? I'm going to stop sharing the oops, hang on, sorry. Stop sharing that visualizer and instead go back to the NRICH website.
I think the first problem we want to look at is a problem called product Sudoku.
Yes. Shall we go straight there, Charlie?
Well, we could go to the second
document.
Let's look at the mapping document.
Okay, so I'm going to go back to the secondary landing page, secondary teacher landing page. I touched on the mathematical thinking and positive attitude sections, but let's turn our attention to this first box, curriculum linked problems. Now, all the problems that we're working on in this session, and indeed in all the webinars that I've been talking about, are curriculum linked. Here, we've got a link to the secondary curriculum map. So this is NRICH tasks linked to curriculum objectives. So Charlie, the first task we're going to have a look at, it has a focus on factors and multiples, I would say. So let's see, I'm going to scroll down. I'm currently on the number tab. Sorry, I didn't make that clear. I'm going to scroll down, factors, multiples, and primes. I would expect it to appear here. Aha, product Sudoku. That's the one we're going to have a look at first. And here we are.
It's got the challenge level at the top, tells you it's a 2-star problem. So that's obviously harder than a 1-star problem, but not as hard as a 3-star problem.
Indeed.
But can feel a little bit intimidating. Can we let's just explain what?
Yes, let's explain what's going on here. Should I? Yeah, okay. So here we have a Sudoku. Many of you will be familiar with Sudokus. So the aim is to complete this grid so that we have got the numbers 1 to 9 appearing exactly once in each row and each column and in each 3x3 square. However, this is called a product Sudoku. So we've been given some clues to help us complete the grid. So for example, I hope you can see that in this top left square, it says 20. And that means that the adjacent squares have a product of 20. So in this case, the square to the right and the square underneath it would multiply together to make 20. Let's quickly look at another example. Here we've got 405 in the square. So this time it's going to be 4 squares that have the product of 405. The one above, the one to the right, the one below, and the one to the left. But this feels, as you say, Charlie, rather intimidating.
Yes, I know 405 will have to have a 5
yes.
on, but goodness knows which of those. And I can sort of divide 405 by 5, and I think I might get 81.
Yes.
And then 81 has got 9s, 3s, and 1s.
And 9s, yes.
And all,
yes.
I've got no idea.
There seem to be a lot of possibilities, though. And so what we're doing at NRICH is we're trying to think, right, how can we scaffold students at this point so they don't just walk away? They don't give up.
But it'd be very easy to have an excuse that this is just too difficult for me. I can imagine just wanting to put my hand up and say, whoa, I don't know what to do.
Too much. Right. So in this particular case, what we've done is, I'm just going to scroll up so you can see a link. There's a link to a sheet here, but also this appears in the Getting Started section. I'm just going to show you in another tab so we can flip between the two. What we've done here is this, as you can tell, this isn't a solution, but we're offering here a route through the Sudoku grid. So where we see a number 1 here, this means that this cell can be filled in first.
There's enough information provided for that cell to be filled without having to guess.
That's crucial, isn't it? No guessing required.
Whereas it's interesting, the 405 that we were looking at, it said that'll be the 73rd cell out of the 81.
Quite a long way through the process.
We've got all the numbers from 1 to 81.
Yeah.
So it's a route
through
the problem. It's not the only possible route. One could have started somewhere else, but it is one possible route.
Okay, and so what we're offering here is a route through the problem, which crucially does not do the mathematical thinking for the students. So shall we have a quick demonstration, Charlie, just to check we...
Okay, so let's just try to remember. So let's try and remember the first 7 stopping places on the route, so on the journey. So cells 1 and 2 can be filled in first. Then these 2 at the bottom, cells 3 and 4. And then these 3 here, 5, 6, and 7.
Okay.
I'll remember them with that.
Yeah. Okay.
Okay.
All right. All right. So going back to our grid, so we talked about this one. So
I wonder whether someone in the chat might want to do.
Good idea.
Okay. So
can we have some suggestions for this?
Now you're going to have a pen. Are you going to be able to scribble?
I'm going to be able to scribble. I'm just going to get the chat up so we can see it. Here we go.
So do you want to annotate those 2?
I will. Good idea. So we are looking at this cell and this cell. So any suggestions? Let's have a little look.
And it was the one on row 2 that had the number 1.
Yeah.
And the cell next to the 20 that had the number 2. So I suggest people write their solutions in that order.
Okay.
What would you put below the 20, first of all, and then...
So this one first, and then this one.
Yes.
Okay. So remember, these 2 numbers have got to have a product of 20. We've got lots of suggestions. We seem to have quite lots of agreement here. And some of you are beginning to give some explanations as well. Fantastic. So I think we're agreed that this has to be 4 and 5. Charlie? And
in a classroom, we would ask students to explain why it's 4 and 5, and we'd expect something like 4 is a factor of 96, but 5 is not a factor of 96.
Exactly.
So, and obviously we can't use 2 and 10 because 10 is too big a number. Now, Liz, could you put circles around a number above the 4?
I can indeed. But these were the next 2, weren't they?
Yes, in the crib sheet it said those 2 cells can now be filled.
And I think it was this one first that it was suggested.
Yes, it was. Yes.
Okay. So in a similar way, I wonder whether you could suggest in order this one, so the one above the 4, and then the one to the right of the 4. So these numbers, remember, got to have a product of 4. Okay, we've got some nice explanations coming through.
And I'm hoping that while you're working on this, you're thinking, oh, this is not quite as scary a challenge as I thought.
Mm-hmm.
And I've used this with some students,
Mm-hmm.
and they've looked at the crib sheet to get started. And then after that, they've stopped using the
Interesting.
You don't
going, yeah.
Just because you use a crib
Yep.
sheet at the beginning doesn't
Yes.
mean you have to use a crib sheet throughout.
Right.
So
here we go. So you've pointed out very eloquently, many of you, that we can't have a 2 and a 2 because that would have a repeat in the same square. So we've got to have 1 and 4, and we've already got a 4 in this column. So we know this one here has got to be a 1, and this one's got to be a 4. Brilliant. And then the next ones, Charlie, were over here surrounding the 3,
above the 3,
I believe, weren't
the
they?
left of the 3 and below the 3.
Okay. So let's have a
notice
think
again,
about these.
Those 3 cells could have been filled at the very start. So the fact that we've
Yes.
done the top left,
Yes,
and then the bottom left, and then this is it's not the only route through this problem.
no, no. So perhaps if you could order your numbers with the top, then left, and then bottom, maybe, please. This time they need a product of 3.
And this is lovely because you'd expect students to start articulating the reasons,
Yeah.
like some of you have been doing in the chat.
Mm-hmm.
And this, in a way, is going to be really good preparation for the kind of conversations that you might want students to have when they're tackling some of the later stages of this problem.
Absolutely. Absolutely. Yeah. Yeah.
And this is a really good activity to do in pairs because you can then check, you can do the explaining, you've got an audience to explain to. We've got printable worksheets for this problem, and for the journey, the route through, and students could just have it face down and turn to it whenever they're stuck.
That's right. That's right. Okay.
So a lot of people are saying ones can't be in the same column.
Yep. And they also can't be in the same square.
Yes.
Okay. So what shall we do here then?
I think there's going to be a 1 to the left.
Let's do 1 here, and then we need a 1 up here.
Yes.
And then a 3 here.
Yes.
Nice.
I'm curious because it's not obvious to me where to go next.
No. That's a good question. Without looking at the crib
Without looking at the crib sheet.
Where might we go next?
Yes. Because that's a discussion you might want to have with the class as well.
It is, isn't it?
Or
yes.
Yeah. Because that's halfway between using the crib sheet and not, talking to each other about what do you think we should try next.
Don't know.
Below the 30.
30. Somebody's saying, where 30? Oh, here's 30. Okay.
So I'm just thinking about 30 could be 1 times 5 times 6.
Yeah.
But it could also be 2 times 3 times 5. Whatever happens, you're going to need a 5.
Right, and we've already got a 5 on that row.
But you pointing at it on your
screen, it's not going
to help anybody.
True. So we've already got a 5 on the top row. So, but we know 5 is a factor of 30, and so the 5 has got to go
here.
Yes.
Nice.
Yes.
Shall we look at the crib sheet and see whether that's the next one?
Okay, I'm going to have to just click off my pencil. Here we go. Ooh. Wow. But you can see
it was the 10th.
Who was the 10th? Oh, so it was
5, 6, 7. So we're at 8 and 9.
Sorry, you can't see my script. Right. I wondered why by the 96. Okay. Yeah. Okay. Brilliant.
Yeah. But of course, putting the 5 under the 30 makes perfect sense.
Absolutely.
Yeah.
Absolutely.
Okay. We shouldn't get too
no, we're not. So we wanted to give you a flavour. So this is a route through the problem. So we're not doing thinking for students. I'm just going to erase all this scribble. Otherwise, it's going to stick on the screen and it's going to be extremely annoying.
Yes, the important message here, if we go back to that flow diagram, we want the challenge level to remain high. We want students to use the skills that they have, which may be, their knowledge about factors and multiples and so on.
Yep.
And but we don't want them to give up. And if they may be tempted to give up because they are not very confident about their factors, or because it feels so difficult to know, they've never seen anything like this before.
That's right.
Then the crib sheet sort of shines a light without doing the thinking for them.
Yeah.
And throughout you'll hear us talking in the same way.
That's right.
If we want to build students' resilience, they need to be at that zone of proximal development where they're working on new material and feel sufficiently confident they want to carry on and not give up.
Absolutely. It's what the authors of this book they call productive struggle. So
you're sharing your screen.
Oh, so I am. So, well, that's not good. Good point.
But
never mind. I'll tell you, we'll show it properly in a minute. We'll show it later.
Yes.
Okay. So Charlie, let's look at another problem where we're sort of scaffolding in a slightly different way.
Yes. So the math doku.
Yeah. Should we go back to the mapping document? I am expecting the math doku to be. It's also linked with factors and multiples.
What about calculations? If we go
good
down.
point. Yes, good point. If you see Math Doku, shout. Oh, here we go. 5x5 Math Dokus. So we have found for you a lovely challenge here. Now you'll notice that it says difficulty 3, puzzle 4. If we click on the cog, there are a whole load of levels of difficulty and different puzzles. So there are 3 levels of difficulty and 5 puzzles at each level of difficulty, I believe.
So and 3x3 math dokus, 4x4,
right,
5x5 and 6x6.
Right.
Yes.
So obviously we're in a similar context. This time we're just using the numbers 1 to 5. We've got to place the numbers 1 to 5 in every row and every column. And this time we're given clues. You can see that we've got what we're calling cages. So numbers shaded. So anything that's shaded in the same color, for example, this L shape, this pink L shape. Here we're told the product of these 4 numbers is 96. Slightly different to the product Sudoku we were looking at earlier. Obviously, it's smaller, but also we're not just talking about products.
What do these 2 mean, Liz?
Oh, yes, good. Okay, so that means that those 2 numbers have got a difference of 3. Because we don't know which way round they might go, just a difference.
So it could be 1 and 4, it could be 2 and 5.
It could.
And it could be either way round.
It could. So in this scenario, rather than offering a route through the problem in the same way that we have with the product Sudoku, we're doing it slightly differently. It's sort of another layer, I guess, isn't it, Charlie? So if I'm looking at this and I'm thinking, oh my goodness me, I don't even know where to start, the interactivity allows me to click help. Show me a square I can solve. So hopefully you have seen that this square here has come up with a yellow border around it. So that is telling us that...
And it belongs...
Thank you.
...to this big set, which has got 1, 2, 3, 8 cells that are up to 22.
Wow.
And I'm being told that I can complete that. Well, I've got no idea still.
That doesn't sound...
That doesn't feel very helpful to me.
So what we can do is, I mean, maybe for some people it would be helpful and they could get going. So that's one layer. But the interactivity does allow us to click to get some more information. And we're being asked a question. Is there a number that can't possibly appear anywhere else in that column? Right.
Okay, I don't want to spend too long on this because we've got 5 problems we want to show you. And of course, we have rehearsed this. But at some stage, you might want students to think about, what we ended up, or you ended up.
The way that we ended up approaching it, but I'm sure it's not the only way.
You thought about these 3 cells that added up to 12. And you realized that there was only one possibility, whereas for 3 minus here,
Yeah.
there were various options.
Yes.
To get a sum of 12, where you're only allowed to use the numbers from 1 to 5.
Yeah, they're all in the same row, so they're going to have to be different, 3 different numbers. I
So
think
it
there's only
had
one
to
way
be
to do
3,
it.
4, and 5.
Exactly. Now, I don't know which order they're in yet, but that's just useful knowing that 3, 4, and 5 are going to be in that sort of purpley coloured block.
Right. And then we thought about the L shape here, where these 4 cells multiply to 96.
That's right. That's right.
And 96 is 3 times 32.
Yes.
And so one of the cells is going to have to be 3.
Yep.
And the other cells...
32 is what? 2 to the power...
2 to the power 5. Now, we've only got 3 cells left.
Yeah.
So you can't have 2 times 2 times 2 times 2 times 2.
Nope. We're going to have to group some 2s. We're going to
So you're going to have 2 times 4 times 4.
Okay.
It's going to be the only way we're going to be able to get 32.
Right. So we're going to need 2 4s. So straight away, that's telling us that... I'm pointing again without using the mouse. This has got to be a 4.
But more importantly, the first column is going to have the 3, the 2, and the 4 there.
Yep.
And in the 12 plus, you had
5, 4, and 3.
So the only number...
So we're looking at this one here.
Has got to be a 1 because 1 hasn't been used. Have I got that?
Let me just check that.
Can you click again on help?
Yes.
So can I solve?
So is a room that can't possibly appear anywhere else in that column. So here we've got 5, 4, 3.
Yes.
Not necessarily in that order. Here we've got a 4 and a 2 and a 3. 4 and a 2 and a 3 here. So we're only left with a 1 and a 5. We know this one can't be 5 because we've used it here. So that's got to be a 1.
Right.
Wow. Yes.
Say that again.
I think. So I think that here we've got 5, 4, and 3 used in this.
So we can't
use a 5 here.
Right.
And we know that these 2 numbers have got to be a 5 and a 1.
Okay.
So that's got to be a 5. What am I talking about? Sorry, I got that wrong. You're right to correct me. This is a 5. The yellow square is a 5.
How do I get rid of this?
Try clicking again. Is that going to take it? No. Okay. Here. There we go. So we think, oh dear. There. That's what we think. Because here we've got 5, 4, and 3.
So we can't have a 5 below where the 5 is.
5 here.
Okay.
Yes. We'll get there eventually. Apologies. You're probably shouting at the screen.
Okay. Yeah. Imagine I'm still stuck and I don't know what to do.
Yep.
I'm going to click on help again.
Okay. And that links to what we've thought about. So that's useful.
So we think we know.
Yeah.
But let's have a look at what the hint says.
Yes.
What are the possibilities for this cage?
Great.
Well, it's 3, 2, 4, 4, and
Yep.
you can't have 2 4s.
Yeah.
So we can fill this. That's good.
That is good.
Okay. Let's imagine we're stuck again.
Yep.
So we can click on help.
Nice linking to our thinking.
I think we know about.
Yeah.
So we know that this is going to be a 3, a 2, and a 4, but we don't know what order.
Yeah.
But there's only 1 hasn't been used.
Yeah.
Let's ask for help one more time.
So this links again to our thinking about 12. So 5, 4, 3. So that's got to be a 2.
This has got to be a 2.
Yeah.
One last one.
Yep. Right.
A difference of 3.
Difference of 3. So it could be 5 and 2. No, it can't because we've used
pointing at the screen.
Pointing at the screen. So it can't be 5 and 2 because we've got a 2 in that.
So it's got to be 1 and 4.
Got to be 1 and 4. And we've got a 4 in this row.
Yes.
Good.
Yes.
Okay. You can see, can't you? I mean, we're not acting. You can see this. We are having to think mathematically. We are having to reason. Nobody is doing any of this thinking for us.
And we have rehearsed.
And we have rehearsed this, believe it or not. Okay, good.
Okay.
So that's a really nice example of some more supporting scaffolding.
So we want students, we're acknowledging that maths can be difficult.
Yeah.
That we're always we're challenging, just like, when you go for a run, you challenge yourself to do an extra mile or to go a bit faster. And as teachers, we're continually trying to encourage our students to do better, to do harder work. But I mean, sometimes it feels like, you're never, your teacher is always giving you something harder to do. And you want to spend a little bit of time in the comfort zone.
Yeah.
But hopefully you start feeling, oh, I can do this. And then I'll have another go and I'll try a more difficult problem, or I'll try another puzzle like this one.
Yeah.
And we're building students' confidence as well as their way of thinking about things and talking to each other. And again, this would be an ideal activity to do in pairs.
I mean, yes, yeah, absolutely.
So the next problem has got a story to it.
It has. Charlie, I think you are best to tell the story because you have experienced it.
When I joined NRICH, on the wall in the corridor to the loo, I used to walk past this poster on a daily basis. And it says, is the number 3 to the power 444 plus 4 to the power 333 divisible by 5? And I'd walk past it and I'd be thinking, well, I've got just no idea. I mean, I don't have any idea how to solve this problem. What a ridiculous problem. And it's just like the kind of reaction that many of our students might have. My daughter was once in school when she was, I think, in year 10, and the teacher gave her class an enriched problem. And one of the children in one of her peers in the classroom said, who has a twisted, cruel mind to come up with problems like this? My daughter and the teacher looked at each other and didn't say anything. But that is how some students think about some of these problems. So it took me, I don't know, 6 months of walking past this poster before I thought, oh, I think I know what to do. And I rushed back to my home desk and figured out what the answer was. Now, of course, in the classroom, we don't give children 6 months to think about it.
We don't, no.
So what we've done is try and simplify. Well, try and offer a different. So we want the students to put this problem aside, park it, and have a go at something else. So we're going to give you that opportunity. I mean, if you know the answer to 3 to the 444 plus 4 to the 3, just keep it to yourself for the time being, and you can tell us later. But we produce a problem called Power Mad.
I'm going to share you. I'm not going to show you the page on the website just for the point in this moment, just because we want to particularly hone in on just a couple of the questions rather than bombard you.
So rather than try 3 to the 444 plus 4 to the, we'd like you to have a go at these two questions instead, and write down in the chat whatever your thoughts are, and if you can include explanations, that would be great. So for which values of n will 2 to the power n be a multiple of 10? And for which values of n is 1 to the n plus 2 to the n plus 3 to the n even? We've got two questions. So when anybody posts a solution, please say whether you're doing question 1 or question 2. And then so a lot of people are agreeing that it's never going to be possible for the first question, and it's always the case in the second question. What kind of reasons might you expect students to be giving? Or what's the reason you're giving? So Eddie has said odd plus even plus odd is always even. And if Eddie was one of my students in my class, I might ask him, how does he know that 1 to the n and 3 to the n are always odd. Now, Yamuna has written something that might help answer that kind of question. So the digits in the ones place or the units column for powers of 2 goes 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6, because you have 2, 4, 8, 16, 32, 64, 256, 512, and then Angela has also noticed that the unit digits repeat themselves for powers of 2.
Mm-hmm.
What happens with powers of 3? Because somebody said that 3 to the n is always going to be odd. Yes, Eddie, we are thinking of n as being integers here. Thank you. Some students may need convincing that 3 to the n is always odd.
Yeah.
Or I might, as the teacher, pretend that I need convincing.
Yeah. Act as a skeptic. Mm-hmm.
So powers of 3 go 3, 9, 27, 81.
Yep.
So the units digits end in 3971. And as soon as we get to a 1, we're going to start repeating, because 3 times 81 is going to be 243.
Yep.
So the 3971 pattern will continue.
Mm-hmm.
And you can see that conversations like this
really
will
valuable.
prepare students then.
Mm-hmm.
And Angela, so second question, last digit repeat. So 1 plus 2 plus 3 will add up to, will have units digits of 6, the total of 1 plus 2 plus 3. Then 1 squared will have a units digit of 1, 2 squared of 4, 3 squared of 9. So that will be 14. So units digit of 4.
Mm-hmm. Mm-hmm.
And then when you cube the numbers, you get 1, 8, 27. And the digits add up to the numbers add up to 36.
So you get
so it's a 6. And I'm not sure I agree with the 7 that comes after that, because I think we've agreed that it's always going to be even. So there's just a little miscalculation there. Okay, enough of
Fantastic,
this. You can imagine spending quite a lot of time on this. And there are, Liz hasn't shown you Power Mad, which is the problem that we've created. And all that we've done is just copied these first two bold questions, but there are many more. There are many
to bombard you.
Yeah. So now the question is, can you go back to the NRICH poster? If I'd had the experience that you've just had, might I have solved this problem a lot sooner?
Joseph is convinced yes.
Come on, Joseph.
Well, I'm assuming he's answering yes to your question and not agreeing with something that's already in the chat. So maybe I shouldn't jump to conclusions.
So, can anybody explain why?
He's had a go.
Oh, sorry. So when 3 is raised to the power, which is a multiple of 4, like 3 to the 4, 3 to the 8, 3 to the 12, 3 to the 444, the unit digit is going to be a 1.
Yep.
Whereas when 4 is raised to an odd power, 4 to the 1, 4 cubed, the unit digit is always going to be a 4. And so because the unit digits are going to add up to 5, whatever the rest of the number is of no consequence.
We know it's divisible by 5.
This seems to be a lovely example of how you can support students. And of course, many of you would possibly not have needed this. And there are many students who will need more than this.
Yes.
But we're trying to acknowledge that this is a hard problem, and that in the same way that buildings sometimes need scaffolding while they're being renovated, while they're being upgraded, we can think of our students needing a bit of that support so that they can carry on without collapsing.
Yes.
I sort of feel if you're not resilient, you just crumble under the pressure.
That's right. I think, just very, very quickly, Colin Foster offers a really nice mental image for this. He imagines, you know, a small child wanting to reach something down from a cupboard. And so as a taller person, you could easily reach the thing down for the child. But the alternative would be to give the child a step, so that the child is still engaged in the action. So the analogy is the students are still doing the thinking. And the book that I was talking to...
Wait, let's stop sharing.
Okay, yeah, good idea. The book that I mentioned just previously, if I pop, yeah, there we go. Where's it? Which is called Productive Maths Struggle. Ooh.
We've got guidance.
Yes, which we'll show you shortly. And this is linked.
Yes.
And they talk about rescuing thinking as opposed to rescuing answers, which I rather like as something to bear in mind when you're offering scaffold.
So you told me about this, and when you told me, and because I wasn't very quite clear about sort of the grammar of what you were saying,
yes,
we ended up thinking that we're rescuing the student so they can carry on thinking.
That's right.
Rather than just rescuing the student so they've got the answer. And this, for those of you who've been to other of our webinars, we've mentioned Peter Liljedahl's work on thinking maths, thinking classrooms.
Yes.
So this is all linked to wanting students to have an experience in our classrooms where they build up their confidence, they build up their self-esteem. They work in a culture where it's acceptable to struggle, make mistakes, as long that this is an inevitable part of learning. And so the 3 examples that we've shown today are an example of how we try and support teachers in supporting students.
Absolutely.
So that they don't have to walk past a problem for 6 months thinking, what a ridiculous problem. Or they can't, there aren't in a classroom where somebody says, who's got the twisted, cruel mind to produce problems like this?
That's right. And so although we've used very particular NRICH examples to illustrate particular strategies of scaffolding for your students, the authors of the Productive Struggle book, they talk about planning for struggle. So that's about the choice of task, and planning to support in a general sense, as well as a task-specific sense. So we'll be updating the guidance that we're going to show you now to reflect everything that we're talking about, so that you'll have everything together in one place. What I'm going to do now is just to end the webinar is show you where the guidance is linked. So this was our big powers. Let's go back to our mapping document. And if I go to the secondary teacher landing page, I'm going to go to the positive attitude page again. Here's our resilience section. And at the very, very top of this page, we've got a link to the guidance, which I'll click on quickly. And as I say, we're going to update that with a little bit more, but just to flag up there, we have linked to particular tasks, some of which you will recognize we've had a go at today, but at the bottom, we've put some more further reading for you. So everything we mentioned, you'll find there. And just taking a step back, if we scroll down this Being Resilient page, you'll also find links to groups of tasks, which are all curriculum linked tasks. But here we've pulled out the ones which we feel particularly offer opportunities for you to support students to become more resilient in different contexts. I think one of the things that we have been reading quite a lot, which I think is an important idea to finish up with, we don't want to label a student as being resilient. I think it's about bringing, as we've said, a mindset. So to a particular situation, we may find ourselves in a particular situation struggling, but then as a teacher, we are offering you some scaffolding, some ways to scaffold, so that students don't see themselves, they don't label themselves as not being resilient.
That's very important, because we know some students who are very resilient in certain contexts.
Absolutely.
They'll persevere even though they're trying to learn a new piece of music, and it's hard, and they don't give up. Or they may be playing sport, and they might do the Alcaraz thing and not give up. And yet they give up very quickly in maths. So something has happened that's meant that they've spent far too long in that bottom right-hand corner, and they've thought that it was almost inevitable that whenever they were confronted with a maths problem, they weren't going to be able to do it. And we must get them into the flow
quadrant.
Yes.
Exactly.
Can I just say?
Yes, please do.
Because we're going to put an evaluation form. Yeah.
Thank you. Yes.
Just one last thing. We realize we've overrun a little bit. For those of you who haven't been to our previous webinars, Liz mentioned that this was the last in a series of 9. And that's because we've done 5 webinars on developing these 5 mathematical thinking skills. And if you click on any of these, you'll find some guidance, and you'll find the recordings of the webinars. And today, we've just completed this resilience, where putting the finishing touches on the guidance. That will be fully operational. It's already available.
It's already available, and there's plenty of there, but there are a few updates
that we're going to do. Unfortunately, not till Monday. But there's guidance on all 4 of the mindsets.
Yeah, thank you.
And we're beginning to think about what the webinars are going to be for next term.
Yes. So any suggestions, do get in touch with us. So I'm just going to pop in the chat now a link to our evaluation form. We would really appreciate if you could just spend a couple of moments giving us your feedback. It helps us do a better job, and it helps us let our funders know how we're getting on.
Yes. Liz mentioned that Trinity College fund these webinars, and we actually had a meeting with Trinity yesterday, and they wanted to know a little bit about the feedback that we'd received. So actually your feedback is very useful.
It is read. Yeah. Thank you so much. We hope you have a really good rest of the day, and maybe see you again. Keep your eyes open on the NRICH events page, where we will be posting details of the webinars for the forthcoming academic year in due course. Bye for now.